Hello my dear friend, welcome to my YouTube channel Mechanical Engineering Management, and this is the Basic Mechanical Engineering video lecture series. Today we are going to see separating calorimeter. So let's see first of all the outlines of the session. First we will discuss about the purpose of separating calorimeter. Next we will see the principle of separating calorimeter. Next we will see the animation of the separating calorimeter so that exactly you can remember the working of the separating calorimeter. Next we will see the working of separating calorimeter, and then we will see the limitation of the separating calorimeter, and at last we will see the application of separating calorimeter. This is the 3D image of the separating calorimeter, so that exactly you can understand the working of the separating calorimeter. So let's see. First of all, the question can be asked in your examination. In which condition of the steam is separating calorimeter mainly used? Draw a net label sketch of separating calorimeter. State advantages and limitation of separating calorimeter. Enlist types of the calorimeter and explain any one briefly. So let's see. First of all, the purpose of the separating calorimeter. It is used to measure the dryness fraction of the very wet steam. In the previous video, we have discussed the barrel calorimeter is used to measure the dryness fraction of the moderate wet steam, and the separating calorimeter is suitable for the very wet steam. Now the principle. Measure the dryness fraction, that means X, of the wet steam by mechanically separating the water particles from the steam. Once you separated these both water particles and steam particle, then put it in this equation so that you will get the dryness fraction of the steam. So here Ms is the mass of the steam and Mw is the mass of the water. Here, keep in mind, my dear friend, Ms plus Mw is actually the total mass of the steam. Now let's see how to draw the separating calorimeter, because of it is little bit difficult to draw in the examination. So first I have drawn the outer chamber, then this is the inner chamber. Here you can see the perforated cup is provided. This is the inner chamber. This is the steam main pipe, provided the steam stop valve, that is called as the control valve also. And here this is the perforated sampling tube, and this is the main steam pipe. So this is actually the pipe perpendicular to this plane. So this device is used to measure the dryness fraction of the steam which is flowing from this main steam pipe. Again here there is a perforated pipe. Here this is the water level indicator, so that you can measure the water level inside this chamber. Here pressure gauge is provided so that you can measure the pressure. This is the valve called as a steam stop valve, and then steam goes to the barrel calorimeter. This is the perforated cup. Now let's see the animation. First the steam will flow from this main steam pipe, and this is actually the flow of the steam. Now let's see the working of the separating calorimeter with the animation. So focus over here carefully. First of all, the steam is supplied to this calorimeter from this main steam pipe through this sampling tube, where it strikes to this perforated cup. So let's see. This is the perforated cup, and here the steam will strike. Due to the inertia of the droplets, water particles are separated and they are collected in the inner chamber. Because of this is the perforated cup. So the water particles are collected over here. so that gradually the level of the water is increased in this inner chamber, and that is sensed by this water level indicator. So from this water level indicator you can exactly determine the quantity of the water inside the inner chamber. So this is the mass of the water, mW. So one parameter that definitely you can find with the help of this water level indicator. You know that this is actually the cylindrical chamber. So pi r square into the h, so that you can find the volume, and by using the specific gravity of the water you can find the mass of the water. So this is very simple. Now next, mass of water droplets is measured with the help of this water level indicator, that is called as mW. Next, the steam is condensed in the barrel calorimeter, where the mass of the steam is measured. So here look at this one. The mass of the steam, which is in the gaseous phase, having low inertia, so that it will strike over here and then separated over here. See the animation so that exactly you can understand. Then it is bifurcated over here and flow in this direction, and then it will come out from this calorimeter and goes to the barrel calorimeter, where the weighing platform is there, and so that you can measure the mass of the steam. So once you got this mW and ms, then put it over here so that you will get the dryness fraction of the steam. Now the limitation of this separating calorimeter. It is only used for the very wet steam. It gives approximate value because X measured by this calorimeter is always greater than the actual due to the incomplete separation of the water, because some of the water droplets may be carried out with this steam. Now the application of this separating calorimeter. It is suitable to measure dryness fraction of the very wet steam, nearly equal to 0.5. Means 50% of the liquid is converted into the gaseous phase. So from that you can understand it is suitable for the very wet steam. Thanks my dear friend for watching this video. Kindly like, share and subscribe.